Hemant has introduced you to the terms microcontroller and microprocessor. Now we're going to build upon those two. We're going to show you what is a microprocessor and a microcontroller with one of the best examples in their domain, that being Arduino and Raspberry Pi. So at the end of the section, you will know what is Arduino, both its hardware and the software. Software being the IDE I'm talking about, and the board, as well as about Raspberry Pi. And by the end of this, you will also know why are we using Arduino in our model. So let's begin. So what is Arduino? So Arduino is an open source platform used for building electronics projects. It is widely used in IoTs and robotics projects. Okay. So it consists of both a physical programmable circuit board or a board in the simple. It's a microcontroller and a software or a IDE. So IDE is an integrated development environment that runs on a computer. So I guess you people are quite aware of what an IDE is. Anyone can give me an example of an IDE, a very common IDE? Anyone from the audience?
JDK?
Eclipse side.
Name me an IDE that you have used in. Hello,
Mini
Yeah.
W, Mini W.
An ID.
hello. Am I audible?
Yes,
Yes,
yes, you are.
yes.
VS Code.
Hello. Yes, yes. Hello. I'm audible, right?
Yes.
Yeah. Okay. Okay. There is some issue here. Yes. So about IDE. So how many of you have heard about Visual Studios, or a very common IDE, like you are whosoever had C++ in their plus two have
Yes,
already heard
yes.
Yes,
about
yes.
Yes,
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 yes.
Turbo
yes.
C++.
Visual
We
Studio.
used Visual Studio.
Yes. So Turbo C++ and about Dave C++. Yeah, the most common of all, Dave C++. I guess you have heard about that.
Yes.
Anyone? Yes. Okay, fine. So these are the IDEs. What does an IDE do? We just write the code. It's a development environment, and the Arduino provides us with that. So Arduino gives us a board. Arduino is also a board as well as an IDE. So moving on. So for the boards, these are some of the examples of the boards. You can see the Arduino Mini, Nano, Mega, Lilypad, and Uno. Okay, so here we're gonna talk about Arduino Uno because it's a very common one, like commonly used one. So a key aspect of an Arduino board is the amount of connectors available. These are the components which permit wiring the Arduino boards to the other components like sensor, resistors, buttons, etc. And we can interact with those components via this board. Okay, so the sensors, for examples, IR sensors, you can connect it to the pins of the Arduino board, and we can take the input from those and process it with the help of this. So Arduino board generally operates between 0 to 5 volt, and the maximum volt that can be generated with this is 3.3 volt usually. Okay, so let's move. Before discussing the pins, okay, the pins, what are the pins? These are the pins. You can see the square boxes here. Okay, these are the pins. So before discussing about these pins, we need to know about the signals. So there are two types of signals: digital signal and analog signal. So what is a digital signal? So a digital signal have only high or a low. There is no in between it. You can see it in this moving graph, if I may say so. You can see that at any point on this graph, you will either have a low or have a high value. There is no in between this. So this kind of signals is called digital signals. This kind of signals is called the digital signals. And in a 0 to 5 volt logic level, the low corresponds to 0 volt and the high corresponds to 5 volt. Okay. Now comes the analog signals. So anyone from the audience, can you tell me where have you seen this kind of graph earlier? Or what is it called?
Sinusoidal.
Sinusoidal
Yes,
graph
correct.
it is.
Yes, correct. So the
Interface.
sinusoidal, so yeah, it's a sinusoidal graph and it is oscillating. As you can see, it's oscillating between the highest value and the lowest value possible. So the analog signals are similarly like that. These signals can have infinite levels. As you can see, since these are oscillating graphs. For example, for example, for the above system, the signal value can be anything from 0 and 5 volts. And it can be 0 volts, 1.1 volts, like this. Okay. So digital signals have only two levels and analog signals can have intermediate levels too. Moving on. So now we are going to discuss about the pins. Pins are the places to which you connect various peripheral components like sensors, uh, etc. etc. And there are two types of pins available. The general input output pins are of two kinds. The first being the digital and the other being the analog. So digital pins are, so these are the digital pin. Can you see the cursor here? Is it visible?
No.
Okay,
No.
okay, okay. There's some issue
Yes,
from
it
my
is
side.
visible. It is
Yes, now it is
lagging
It's
actually.
visible.
visible.
It is visible, but
Yes,
it
it
is
is
too
visible.
small, Didi, actually.
Yeah, yeah,
It's
visible,
highlighted.
visible, visible.
Okay, okay, okay. Leave it. Some net issues might be from my side only. Leave it. It will not create any problem. You can still understand it. So you can see that there are there are D0 to D13 digital input output pins range from D0 to D13 and the analogs from A0 to A5. But importantly is that is the D0 and the D1 pins are the serial pins, okay, and they are used for serial communication. So we're gonna discuss about that in the later parts. But what is important in this is that you must know what are the digital pins and what are the analog pins, because they are the general input output pins, and whatever we're going to connect with the board requires them to function properly, so you must know them. So moving on. So as I told you, the pins are level from A0 to A5. These are analog pins. They can input and output analog signals. Next is the ground pin. You know what is the use of the ground pin? It is used to just ground the components. Okay. Next is the VIN pin. It is used for supplying the external power, okay, to the board. Then there comes the 0 to 13, the digital pins. And there is 5 volt and 3.3 volt. There are just like the power which can power the sensors and the modules. Okay. Now, as I told you that the pin numbers 0 and 1 are used for serial communication. These are RX and TX pins. Okay, these are not generally used for GIOPs, like general input output, but specifically for the serial communication. Serial communication as in Bluetooth, as in transistor to transistor power data transfer. Okay, not very often used, but yeah, important. Okay, so moving on. So this was all about the boards. Okay, this was all about the Arduino board. You can see here that it has a microcontroller inside. This Art Mega 8 series, it is a microcontroller and a pretty important microcontroller. Although it has improved in recent days, is an old model, I guess. So yes, and these are the digital input output pins. This is the ground pin, analog reference pin, and the serial input out pin that I have told you here. You can also see the voltage pins and the ground pin, that the 3.3 volt pins here and the 5 volt pin. I think it's visible now. And this is the USB plug
Yes.
to which, yes, and this is the USB plug. You can use it to connect to the computer. You can use it for any connection like which requires USB. And this is the power supply plug. So in this way, this Arduino UNO board function. The main heart of this Arduino board is this microcontroller. So yeah, moving on.
Excuse me, Didi.
Hmm.
What is the use of that analog reference pin?
You will understand it when we move forward.
Okay.
I even I have one like in the side of the pins, right? The analog and the digital pins. There are those whole kind of thing in the board. Are they of any use?
Sorry, what you just said was like not. I could not hear it properly. Can you please repeat it?
At the side of the analog pins, right on the board, there are those holes in the board. At the side of those 0, 1, 2, 3, 4, 5, 6, and pins, there are those holes in the board. So are they of any use?
Of course, there are views. You were talking about this or this.
Not the black ones, the on top of it, I think.
Wait, let me. Are you talking about this or
Isn't it?
this? Hello.
The holes on in the board, not the where you put in the wires inside.
Actually, he is speaking that the physical board, that is, I think it is for use for connecting to the module like pin a physical hole, दीदी. Not for the any output connectors.
Yes, yes.
That is
Yes, these
this, I
are.
think, used to connect it with body of something like to fix it properly.
Okay, it is
Uh,
just for attachment purpose to some other place.
Ah, yes,
Sir,
yes.
Didi, it is in
I
right
am.
at right side.
I'm sorry. I cannot understand what you are asking me. But these holes are like, these are the pinholes. Like you have to connect it. This all this problem because I've not seen the wires. So these are like some needle like wires. So you have to connect it, put this inside this hole, and you have to connect it to any of the peripherals of your choice, be it sensors or whatever. So these are the holes that help us connect to the sensors or any peripherals, any input output device you want to connect to. This is all I have understood from your question.
Didi,
So
are you
uh,
able to see reset button? Reset button.
okay, you are speaking about this.
No, no, reset. That is crossing one hole. Means line, the red line that is being used for indicating reset button. That is crossing one
Yes.
hole, white hole.
I'm sorry, I cannot understand what you are
The
asking.
holes, the holes for the screw, I think
Yes,
screws.
sir. It's the holes for the screw to
This
Uh,
fix.
one,
yeah.
this one,
Yes,
Yes,
this
yes, yes,
one.
sir.
Yes,
this.
yes,
Yes.
yes.
That's what he's asking.
Yes,
That is
yes,
used to fix in.
these are the, yes, exactly, for fixing the board. These are used. They have no use for the input output. Yeah, these are for fixing the board to any of the surface we want. Okay, okay, moving on. Okay, so here we have discussed the basics of the board. That much is required for a project. You can just like, if you want to read about this, you can read. There are many articles, documentation for this various Arduino. If you're interested, you can read it out. So moving on. Now we're gonna discuss about the software part. Okay, open source software, that is the Arduino IDE. So this Arduino IDE is compatible or suitable for all of most of the operating systems out there, Windows, Mac, Linux. You can work on any of this. So it supports the language C and C++. So now you know why we taught you C in this. So if you know C, even the basics of the C, you can understand how to write codes in Arduino. So moving on. Yeah, one of the important thing is that the extension in which it is saved is .ino. So yes. So once you open the Arduino, this is how it's going to look like. Exactly now, like this, it is going to look like. You can see file names, the toolbar button, the add here is a text editor. You can edit the code, write the code, edit it, save it. Okay. There are two important functions that you can see. The first being the setup and the second being the loop. We're going to discuss what are these and what importance do they hold while writing the code in Arduino. So the toolbar, it's a toolbar. You know what the toolbar is. You have seen it in various other applications too.
Yes.
So yes. So uh, this is a verify button. It's a verify button. What does it do? It just checks if there is some error in your program or not. It just outputs if there is any. It's for the saving. It's for opening. And similarly, what is important and something that you have not seen is the serial monitor. We're going to discuss about the serial monitor in the coming slides. So yeah, you know what is verifying. What you know what is save. Verify is to check for the compilation error of the sketch. Okay, and now comes the serial monitor. Let's read it. So the serial monitor is a button present in the right corner of the toolbar, as just we have shown you, and it opens a serial monitor. So when we connect the serial monitor, the board will reset the operating system on whatever we are working on, Windows, Linux, Macs, whatever. And if we want to process the control characters of a sketch, we need to use an external terminal program. The terminal program should be connected to the COM port, which will be assigned when we connect the board to the computer. In other words, if you have not understood whatever written here, in other words, it allows the exchange of data with the connected port on the connected board on the port. So, for example, if I am connecting the UNO board with the with my system, with my PC, and I'm writing some datas, okay, I'm writing some code, and I want to see how it is functioning in my board, and I want to see whatever the data it is reading from the board or writing on the board. I can use the serial monitor. It will show me whatever is going on. The exchange of data, whatever is going on, it will show me. Okay,
Didi,
moving.
what does the reset? Can you show the previous? Yes, the board will reset on the operating system. What does this mean?
Look, here we have told that we need a terminal program. Okay, here I've told that we need a terminal program connected to the CM port. So the board will reset the operating system on whatever we are working on.
Didi, you are not
You are
audible.
muted. You are muted, Didi.
Which I have to something we have connected to. Okay,
You are
The
not audible for some
You were
time.
not audible.
I
I
think
am
need
not
to say.
audible.
I
I am
think
not audible.
You were
yes.
not audible back there when you
Was
explained.
kind of this.
For some time, you means you totally muted.
Is it? Am I audible now?
Yeah, yeah, yeah.
Yes,
Explain
yes.
it,
Now,
explain.
Yes. Hello.
Hello.
yes, Didi, you are audible.
Yes, you are audible now.
Yes, Didi, now you're audible.
Yes. So my point was that key whenever we connect the serial monitor, you need not to think about it. The board will reset the operating system. Okay, because as I have told you that a terminal program should be used. Okay, a terminal program that is connected to the COM port, which will be assigned when we connect to the board. Okay, as I've told that there will be a terminal program, and whenever you connect to the serial monitor, the board will automatically reset the Windows system or the system in whichever you are working on. Mm, to understand the basic functioning of the serial monitor board, you just need to understand that it just inputs or output. It just shows us whatever the exchange is going on between the board and the computer. Okay, whatever exchange. Suppose we write something on the board, on any of the pin of the board, okay, it will be shown there. And if we intake some data from the board, from any of the peripherals of the board, it will be shown there. So this is the important, this is what the serial monitor does. And if you want to see what the serial monitor does, you just have to hold on for a day. In the next session, we're going to show you the complete functioning of a Arduino using it, like a simulation we're going to show you. Okay, this is how it's going to work.
Means
Had it been,
hello
yes,
Di.
yes, please, yes, please.
Means in previously when we firstly connect the Arduino board to our PC or laptop, then in previously in Arduino board the coding is to summarize, or we have to make the code in the Arduino board with connect my PC.
You can do whatever you like you can keep it connected and write, and this then pass it on to the board. You can upload a pre-written
means
code
means
to the,
means my question is, when we open a new Arduino board, the code
yes.
is already a something code. I mean, I have not written any specific code. Means any specific code has to be written there, or we have to just scratch to build the code to connect my laptop to that Arduino board.
No, you don't have to write any code to connect. Like you have to just tell, you just have to tell the initializer to set, what should I tell you, like, okay, I will show you in the coming slides what I am telling you to do. Okay, you will
Oh,
understand when I show you the code. This is
oh,
how it's going to work. Okay,
okay.
uh, it is not possible to explain it to you via words what it is. I'm going to show you in the coming slides with an example of the code. I hope it will clarify all your doubts regarding this.
Okay, Di.
Yes. So here is the most weighted part, that is the programming in the Arduino. So here is the basic structure. You saw it. You saw that when you were just opening the Arduino portal, the two functions that were pre-written were the setup function and the loop function. So the setup function is a function that is used only once during the code. And the loop function, as the name suggests, it loops the statement that is written inside. So whatever you want to run once or initialize once, okay, you're going to write it in the setup function. And whatever you aspire to run in a loop, you will write it there. So the setup, so sum up, the setup function is a preparation, is for the preparation, and the loop is for execution. Both functions are required for a program to work. Remember, even if there is no statement there to use in the setup, you still have to include the void setup function in the program. These have to include it no matter what. Okay. Now moving on, the setup function should follow the declaration of any variables at the very beginning of the program. It is the first function to run in the program, is only run once, and is used to set pin mode or initialize the serial communication. So it is used to initialize the pin mode. What is that? What is the initialization of the pin mode? We're going to discuss in the later parts. And the loop function follows next and includes the code that needs to be executed continuously. So like reading inputs, okay, writing the outputs or triggering the outputs. These are the these are some of the statements that needs to be executed continuously in a loop. So we write it in the loop function. And this function is the core of all Arduino program and does the bulk of the work. So it's the code which whatever write inside that loop function is going to determine what your program is going to do. So now let's discuss each of the function individually. So setup function. The setup function is called once when your program starts. Use it to initialize all pin modes or begin serial, and it must be included in the program even if there are no statements to run. So here it is. An example of initializing a pin to a specific mode. You will see a function that is pin mode. and we are going to discuss what a pin mode is in the upcoming slides. So next is the loop. As we told, as the name suggests, it is looping. It's for use for looping the statement written inside it. So after calling the setup function, the loop function does precisely what the name suggests. It and loops consecutively, allowing the program to change, respond, and control the Arduino board. So void loop, here it is written. So each time the loop runs, these very lines or statements will be executed. Okay. And what are these? You will understand in the later part. Okay. Now we will discuss some of the functions, some of the Arduino functions. So Arduino functions are the inbuilt function are pretty easy to understand if you look at their name, because almost all the time you can suggest what they're going to output just by looking at their names. But before this, I hope you have understood what functions are from whatever Durbar has explained to you. What are functions? Can anybody explain in the easiest way possible?
A function is the set of instruction which the computer needs to like perform. We can just, instead of typing the whole code required to perform a specific task, can be just done by calling that function to do it.
Yes,
A
exactly.
function is
These
an easy way of recursing a statement many times.
um okay, kind of true, but the function is something that requires an input and will perform something and give us the desired output. This is the very basic example, like definition of a function. It will give us the desired output that we need based upon the statements that we have written. So input, processing, and then output. This is what a function does. So we have already discussed about void setup and void loop functions. Now we can write custom functions, obviously. We have discussed how to write custom functions. Durba has discussed how to write custom functions. But there are some inbuilt functions that are already there, already defined, that can be used and are very commonly used while writing the program. So how does a function look like? A custom function, you will write type, function name, and the parameters, and the statements that inside the parenthesis, you will write the statements that you need to process. So moving on. Now, variables, you know what is a variable? Can anybody explain what is a variable?
Which continuously changes throughout the program. It doesn't have a fixed value.
Yes,
Which
it doesn't have a fix. Yes, yes, please. Yes, please. Whosoever
It's
was
kind of
speaking.
a storage container to store a particular data.
Yes, very good. A good way to define what a variable is. Yes, correct. So variable is just as you said, a container to store some numerical value that we're gonna use in the later part of the program. And as the name suggests, its value can be modified according to the statements. So this was variable and functions. Now we're gonna discuss some of the commonly used functions that we use. Okay, commonly used functions in the Arduino. And as I have told, the name of the functions are enough to tell you what they are going to give you as an output, or what they are going to do. Okay, so for example, here it is pin mode. The function is pin mode. And what are the parameters here? Parameters are the pin and the mode. So it is used in a void setup to configure a specified pin to either behave as an input or output. So if you remember the board that I have shown you, and I've told you that there are digital pins and the analog pins ranging from
Yeah.
uh, yes, analog pins from 0 to 5 and digital pins from 0 to 13. Okay, working from 2 to 13, you can say that. So these pins can either behave as an input one or as an output one. So what does that mean? Can anybody explain? Like, what do you think that it means to behave as an output or an input one? What do you think it means? Just
Like
yes.
when it behaves as an input, it will input and signal, and whereas when it behaves as an output, it will give an desired output signal. Like that. That's how it's gonna work, I think.
Okay. Okay. Yes. Correct. Almost correct.
Like when
Yes.
we
Yes.
say pin mode in output, um,
Hmm.
like which pin do we specify to be an output, or does it make that whole row an output pin?
No, no, not the whole. Just the pin that we have specified is going to make it either output pin or input pin. For example, if I say that I'm going to specify the D0 pin, not D0 pin, let's suppose D4 pin, okay? The D4 pin to the output pin. So only the D4 pin will act as an output pin, not the rest of all. The rest of all can be initialized for input, output, whatever we like it. Okay. So yeah,
Okay,
this is what. Yes. And one more thing is that the digital pins are by default to input, so they need not to be explicitly initialized with their input mode. Okay. So the pin mode function, once again, the pin mode function, as the name suggests, initializes the pin to a specific mode. The parameters passed here are pin and the mode. Yes. Next is the digital read pin. As the name suggests, the digital read. So what it is going to do, it is going to read the digital signals from a specified digital pin, and we know the digital signals are either high or low. So the pin that we're going to specify here will the program will read the value it gives us. It can be either high or it can be low. So for example, if I take a variable value and I initialize it with digital read pin, and suppose in the pin we pass the D5 pin, okay? So I pass the D5 pin, and whatever the signal that is going to come, the digital signals, we're gonna read it from the digital read function and store it in the variable value. Okay, so I hope this makes sense.
Ma'am, can you
Hmm.
please explain with an example? It's
Okay,
little
yes,
bit
yes. Of course, I will explain with an example. I have added a code in the latter part. Okay, but anyways, I'm explaining you here only whatever I am, whatever pin I am passing as a parameter, okay, to this function. As I've told, I am passing the D4 pin. Suppose the D4 is connected to a sensor. Okay, suppose the D4 is connected to a sensor, IR sensor, suppose. So the sensor will sense and will uh, return some value, return some input to the board through that pin, and we will read that value from the digital read function. And whatever the value we get, we're gonna store it in the value variable. I hope it is clear now.
Yes, yes, ma'am, clear.
Yes.
Yes,
Thank
the
you. Thank you. So now it is digital write. As the name suggests, we're going to write the digital values of the digital output to the pin mentioned here. So it is here. So output are either logic levels high or low. Outputs either logic level high or low because it is a digital pin, a specified digital pin. The pin can be specified as either a variable or a constant from 0 to 13 because these are the digital pins. So if I write digital write pin and high, for example, if I mm, want to, suppose there is an uh, like what say, suppose there is a peripheral that we have connected to the board at pin number D7, okay, and we want to switch it on or switch it off. These are the two possible things that we can do to that very peripheral. So either we can switch it on or we can switch it off. So suppose I want to switch it on, so I can write digital write and the pin number that is D7 and can write high. So um, uh, we are going to pass a high level of digital signal, okay, and we're gonna tell the peripheral to switch on, okay, because there are only two possible levels, that is high or low, that exactly turns on or off. So in this way, we can use the digital write function. Okay, now moving on. Next is the analog read. So it reads a value from a specified analog pin with a 10-bit resolution. This function only works on the analog pin 0 to 5. We have already told there are A0 to A5 are the analog pins, and this works on only that. The resulting integer values range from 0 to 1023. So it's a 10-bit resolution. That's why we get this range. And the value is equals to analog read and the pin that we're going to read. So we're going to pass the pin number from A0 to A5, whatever the pin we want to read, and we will store it in the value, just like we have done for the digital read pin. Similarly, it's similar to that. Okay, and note, analog pins, unlike the digital ones, don't need to be first declared as an input or output. Okay, now moving on.
Didi, can you please tell the reason behind this?
For
For the last one, note the previous slide. The reason behind analog pins do not need to be first declared as input or output.
and what were we doing for the digital read pins?
Like we were first declaring is that input as input or output, or it was initially declared as input. So
No, it was not declared as input. No, it was
like
not
as
declared as
default,
input.
like somewhere.
It was by
Digital
default.
pins are by default.
Yes. Uh, whosoever is speaking, kindly repeat.
In the digital ones, like the pins are by default input. So in order to output, we need to declare it as an output. But in case of analog pins, like how will it understand whether it is for input? Don't specify.
Please repeat what you said. Like your voice is not clear. I'm sorry. It might be my network problem, but yeah, cannot hear whatever you said.
How do
Hello.
we specify analog pins are an input or for output purpose?
Yes, we have specified, right? We just said you that we are specifying it in the pin mode.
Oh
We
yes.
said, na? Yes. We said that we're gonna specify the pin mode function and the Arduino digital pins. The digital pins need not to be specified as an input because they are by default to that. Okay. So, so the next comes the analog write pins. So writes. Okay, hold on with this
Sorry to
analog
interrupt.
write.
Did you say about that? I asked one question.
What did you ask?
That why analog does not need to be declared input or output like that of digital pins.
No. It is not correct. Analog pins need to be initialized. I am sorry for this, but it needs to be initialized.
Okay.
For yes. I'm sorry for this.
And what does that 10-bit resolution actually mean? Like, is it the size?
Yes, it is the size. So what does a bit represent? What a bit can represent? What are
Zero
the
and one.
values of bit?
Zero,
Zero and one.
Yes,
zero,
yes, yes, correct. So one bit can represent 0 and 1. 2 bits can represent how many values?
1024.
No. 2 bits, how can?
Oh, sorry. Four,
will
four.
represent the four
Yes,
values in
four
combination
values.
of 12.
Correct. So 2 to the power 2. How many can 3 bits represent?
8.
The power
Correct. Yes, 2 to the power 3. So now calculate for 2 to the power 10.
1024.
Correct. So from 0 to 1023. All good?
Yeah.
Yes.
Understood? Yes, fine. So this analog write pin, this can be a bit confusing, but you need not to go into its theories too much, but I will still try to make you understand whatever is happening on. So analog write pin, you can understand we are writing the analog signals, analog values into the pin specified. Now what does this value stand for? This value stands for the cycle. Okay. um Let me see if I can show you. Let me see. Wait, let me see if I can show you the cycle here. Yes, I hope it is visible. I thought of skipping it, but yeah, you guys are asking questions, so I thought let's show this to you. So um, here is the PWM cycle. Okay, it's a PWM cycle. So you saw in the digital read pin that we are sorry analog read pin. We are specifying two parameters. Former being the pin number, and the second being the value. So in the value we specify the duty cycle. And what does this duty cycle mean? This duty cycle means, suppose uh, it ranges from 0 to 255. Suppose I say I write the value to be 255. So almost 100% of the time it will show high, it will show high levels of voltage. Suppose I write half of the 255, that is nearly equal to 140 127, I guess. Yeah, if I'm not wrong calculating. Yeah, it will be 50% of the duty cycle. What it will do, it will show 50% of the low levels, 50% of the time low levels, and 50% of the time high level. For similarly 25% of the 255, if I mention, it will show 25% of the time high level and rest of the time as a low level. You can understand this if you read it. Like, it's not that important while writing a code, but yeah, you can obviously search for it and understand what does a PWM cycle means. Okay, so moving on. So this was the analog write pin. Simply, you just need to understand that we are writing the analog value to the pin specified, and it can generate a steady value between 0 to 25 to 55, and that is 0 to 5 volts. Okay, and it alternates. Okay, that's the basic you need to understand. If you want to go, I'll just brief it out. If you want to uh, go in like if you want to understand more, you can just search about PWM and the modulation with modulation. You will understand what is going on here. Okay, I don't have that much time, otherwise I would have. And let's move on. Then one of the most common example of function is the delay function. Okay, the delay function, as the name suggests, again, it just pauses the program for the amount of the time specified, and usually the time is specified in my milliseconds. Okay, so if I specify delay thousands, that means it is going to pause the program for 10 milliseconds, 1000 milliseconds. Okay, that is 1 second. Next is the serial begin function. It is a function that opens a serial port. What does it do? It begins the transmission of the data between the board. Okay, between the board and the system that we are working on, or whatever we are writing, it begins the transmission of the data through it. So it opens the serial port and sets a baud rate. So what is a baud rate? Roughly it can translate into symbols per second, or you can tell the data per second that is transferred between the board and the through the serial connection. Okay, so suppose I mentioned the serial dot begin 96 9600 9600 bps. So I mean that I'm setting the data rate to 9600. And okay, now you can see that we have defined the serial.begin function in the void setup. Can anyone guess why we have defined it or written it in the void setup function, not at the loop function?
Like we need to run this statement only for once. No, there is no need to loop it several times.
Correct. Yes, exactly correct. We don't need to loop it. So we have initialized this here in the setup function. It will just open the serial port and the transmission of the data will begin through this very statement. Okay. Hmm.
When we
Now
say it will open the serial port, does it mean like are we the user is going to input some values in the serial port so that it will be processing?
it will begin the what is that called, serial port, and whatever we have written in the program, it will execute, and you can see it in the serial board that we have talked about. Okay, understood what I'm trying to tell you. It will begin the begin the function. It will start the transmission of data. Okay, and we will receive data, we can write data, and whatever is going on, we can see it in the serial board that we
Now,
have
what
talked about.
BPS stands for?
What? Bits per second.
Okay, okay.
Okay, the questions regarding the serial boards and the serial communication, um, I hope it will be clear when we will show you how the simulation works. Okay, there they will show you coding in the Arduino. So I think it will become clear for you to understand what does the serial board means. Uh, what does resetting means. Okay, whatever is associated with the serial connection, you will understand, I hope. Okay, moving on. So there is the another function, that is serial.printin data, that prints the data to the serial port, whatever they want to print. Okay. So followed by an automatic carriage return line. Just important is that you understand the code here. Whatever we are doing, we are just printing this analog read of this, whatever this analog read function is outputting here, we are writing it in the serial port. This is what it is, and its usage you can see clearly when we write the program. Okay, because if I'm going to explain to you, it is going to take time. Okay. Okay, moving on. So here is a program that I was talking about. You can see a program on whatever I have told you. Can anyone explain me whatever is going on here? Like, you can, you don't need to explain me statement wise. You just can explain me in a bulk, like whatever is going on. Brief me about it if you can guess. Comments are written. You
The
can
LED
read it.
bulb is blinking. Light is
No,
blinking.
no, that's not what I'm asking. I'm asking, explain me what the program is doing in a brief. How is it taking the values?
The firstly you can explain this, and another you have given, and we have to means we have to interpret that. Firstly you have to explain this, please.
We say that there is an LED which is connected to the board, and we have defined the three parameters for the LED, which is for the control. One is for the brightness of the LED. One is like how it will dim out. So basically, when the code will run, it will first on the LED on some particular brightness. Then there'll be some timer set which will tell how slowly the LED light will fade out and stop off completely, and again it will start after a few moments, kind of like that.
Yes, yes, correct. That is what is happening basically. Let me explain it. So the LED is equals to 9. We have initialized the LED is equals to 9. That means to the ninth pin we are connecting the LED to. So as we have said, in the void setup function, we initialize uh, and run the statements that are and we write the statement that are used to run once. So we are initializing the pin 9 to the output. Okay. Next is the loop function. So can anybody tell me what is this pin 9, digital pin or an analog pin?
Pin.
Yes?
It's
Analog.
analog pin.
Yes. Okay. Now we have the, what is that called? What did you say? This analog pin or digital pin?
It's an analog pin
An
So
analog pin
how?
because pin mode.
Yes.
because we are using the function analog, right? So from there we can
But
say
the output is fixed. It is analog pin.
Sure. Are you sure that is analog pin? Because I have told you that there are only 0 to A0 to A5 are the analog pins.
Yes, ma'am.
Think
It is
about it. Okay.
digital.
Okay,
There
okay,
are
okay, fine, fine. You think about this, and by the end of this, I shall ask you once again, what are this? What is the pin by the end of this? Okay. And you have to tell me what the pin was and why are you saying that. So okay, so LED is initialized to 9 and the brightness to 0 and fade amount to 5. So LED brightness and fade amount are just the variable. Okay, we are initializing with 9, 0 and 5. So we have set the pin mode to the output. Now next, there's a loop. As the name suggests, it will loop. So we are writing analog write. Here we are writing an LED. LED is 9, the pin number that we are already specified, the 9 pin number, and the brightness. So here we are using the function analog write. So the brightness value must be between 0 to 255 as we have already discussed. So from 0 to 255, any value will be accepted. So first of now we have to change the brightness. How are you going to change the brightness? Brightness will be changed like brightness is equals to brightness plus fade amount. So fade amount is 5. So whenever the loop runs, with each iteration, a fade amount will be added, that is 5. Okay. 5 is the fade amount that will be added each time the loop runs. Now we're going to reverse the direction of the fading at the ends of this fade. So if the brightness is less than equal to 0, or the brightness is greater than equal to 255, fade amount is equals to minus the fade amount, and we will wait for the whatever is happening here. I hope I think it's not clear to you all, but we are not going to the logic now. We're just focusing on how to write this code. So if you want to learn about the logic, maybe if I get time I shall be explaining you at the last. Okay. Now and the function that we have used is the delay function. As I have told you, what does the delay function do? The delay function delays the program by the mentioned millisecond. So it is the 300 sorry, 30 milliseconds. So it will delay the program each time the loop runs by 30 milliseconds. So if I run this program, it will fade the brightness of of a LED that is connected to the board. And how we are going to do this? We are going to use three of the important function, that is a pin mode function, analog write function, and the delay function. Okay. And okay, so this was what it was. And moving on. So you guys know how to write logic, right? You have how to write statements in the C.
Yes,
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 ma'am.
sir.
I don't think many of you do know, because not everyone had C++ or Java in their plus two. Mm,
I have Python. I don't know.
Python is quite similar to this only. Not that different. Okay, anyways. Mm, moving on. If I get time, I will tell you the logic, what is happening here. Okay. So now moving on. So why do we use Arduino? So first point is that not only we use, it is used by teachers, inventors, students, hobbies, everyone alike. And it is very easy for the beginners to use. Whosoever has any knowledge in C, Python, or C++ can just read the code and can tell what is happening here. It's pretty similar to C. I mean, almost similar to C. And it is very flexible for the advanced user too. So another is that, as we have already told, that it runs on all of the three major systems: Linux, Mac, and Windows. Then it is low cost. Okay, it is very low cost as compared to the others. And yes, of course, some of them consider it to be the first step of the robotics. There are many key tool to learn new things. Yeah, and yes, it has a big user community for the help. So yes, so this was all about Arduino. And next we're gonna move to a, okay. So tell me, after all of this, what do you think Arduino is? A microcontroller or a microprocessor? Any guess?
Microprocessor.
It is both.
Okay. Okay. Anybody else with any other opinion about this?
It can be said that it is like it processes the code and controls the robot. You can say that.
Yes, it can be done by both microprocessor and microcontroller. So, what does in which group do you place Arduino to into? Arduino UNO into here.
Both.
No,
I
both is
think
not
more
a.
probably processor.
Yes, yeah, ma'am. In if we give into a input something with help of microcontroller, they can process it and give some output. That's why I am saying that Arduino is an microprocessor.
So, what is the difference between a microcontroller and a microprocessor?
Controller means to means to there is a specific task that to control that process, and processor is to a whole of the part.
And
I
so, Arduino falls into.
Processor, yes.
Okay, I hope after this, okay, you are not right. You are wrong. I hope you will understand after this what it is. Okay, after I explain Raspberry Pi, and I hope you will understand what is the difference between a microprocessor and a microcontroller. Okay, so what is Raspberry Pi? So this is how a Raspberry Pi board looks like. It is a mini computer, and it is not an exaggeration. It is really a mini computer. You attach you attach any of the input output devices, keyboard, a screen or a monitor to this. It will function as a small computer, and I don't need any other thing for it to function. Even it has its own operating system called Raspberry Pi OS, which is a yes, a version of Linux. So what is a Raspberry Pi? A Raspberry Pi is a fully functional computer that can be plugged into a computer monitor, keyboard, and a mouse. So you can add computer monitor, keyboard, and mouse to this Raspberry Pi, and it will function just as a computer. Okay, so it has all the qualities of a PC: a dedicated processor, memory, and a graphics driver. So you know what? This Raspberry Pi is used even for the image processing. Like a very famous utilization of this Raspberry Pi is in the image processing. And even more so, the Raspberry Pi series, some of the boards have Ethernet too, like the internet. It has inbuilt Ethernet. So and also has a based Ethernet socket. So it's a small computer. It's a pretty small computer with all of the functions that you need is there in this. So moving on. So what is the uses of Raspberry Pi? As I told you, it is capable of doing everything you would expect a desktop to do. Everything from browsing internet, playing high definition video, to making spreadsheet, word processing, and playing games. Uh, just by looking at this board, you might think how is it, how you might ask how is it possible, but you can search for a Raspberry Pi kit that is available. Yeah, I think I've seen it in the Amazon also. So there they give you all those peripherals with it, and you just can add it and just set up the function, and it just functions like a small computer. So moving on, yeah. So now we're going to differentiate between a Raspberry Pi and an Arduino. So Arduino is a microcontroller and the Raspberry Pi is a microprocessor. So if you look at the Arduino board, why I'm telling it is a microcontroller is because if you look at the Arduino board, it has a integrated chip. That is the only thing it has. That is the heart of the Arduino board. Uh, uh, that is called a microcontroller. So whatever Arduino does is through that. So it is a microcontroller. And what is a microprocessor? Microprocessor are a fully functional computer. It just it has microcontroller in it, but not only microcontroller. So every microprocessor has a microcontroller, but not the vice versa. It can do everything. Uh, it can do everything a computer can do. So CPU is a processor, and the chip inside it, the integrated chip inside it, very small chip, you can call it a microcontroller, just like you Arduino has. So this is the very basic definition difference between Arduino and the Raspberry Pi. So each of them are examples of each. Like one is a microcontroller and it's a microprocessor. So Arduino boards are the microcontrollers, not full computers. Okay, while Raspberry Pi boards are microprocessor, fully functional computers. Even it has a very high flash memory too. If you look at the Raspberry Pi, you will find it has a 16 GB of uh, that flash memory, and it's Ethernet. I said it has Ethernet too, and its own operating system too. So then Raspberry Pi has it. Yes, I told you the operating system. While Arduino board works on a simple instruction, so it works on IDE instruction that we have provided them by the IDE. While Raspberry Pi has its own operating system. So without the simple instruction by the IDE, the Arduino cannot function on its own. But the Raspberry Pi has its own operating system, and that basically differentiates from the Arduino. Next, I told you Raspberry Pi supports internet, and of course, Arduino board does not have its own internet and does not support. And uh, yes, these are the very basic difference between the Arduino and the Raspberry Pi. The only thing that you need to think uh, to decide whether it's a microcontroller or microprocessor is that the very definition that controllers are not fully computers, whereas microprocessors are. And the best examples of each of them are Arduino and Raspberry Pi. So yes. Now the question is, why do we use Arduino in our model? The reasons are they are self-contained, including all necessary peripherals on a single integrated chip. Okay. Then they are designed to run a single dedicated program, or they can be designed to run a single dedicated application. Okay. They can be optimized. Okay. Both the software and the hardware can be optimized. Okay. For a specific program that we are trying to make. And then they exhibit low power consumption and may include power saving features. So yes, this is a very important feature, is that they use very low power consumption, and they can run for a quite long period of time without any interference, without any user interference. Okay. Interference. And the most important thing is that they are relatively inexpensive. So when you compare it to with CPU, with Raspberry Pi, they are costly. Okay, they are costly. Arduino is not that costly, so it is inexpensive, and it gives an advantage over others. So this was all about Arduino and Raspberry Pi. Before concluding, I want to tell you that whosoever has a confusion for the serial port and the how serial communication is working, I know it is not quite easy to tell you through this, because it would have been easy if I could show you. If you were in the offline mode, we could have shown you how the connection works. How do you connect the serial port with the Arduino? Even I hope that we are going to show you to the simulation, but still, it would have been better if we could show you in the offline mode that how a serial port is connected, how a serial communication works. Um, For as of now, I can tell you, you can look some of the videos, live video, some of the videos on the YouTube where they have shown the what is that called, working of a serial port. Serial port is like what is, it's not a, something a big deal, but yeah, you can look up, you can look at the YouTube and can see. It's interesting. Yeah, that's all from my side, and I hope it's clear.